metric earlier, and there's a review of that here as well, which is nice. Ooh, and we're gonna do the Friedman equation math here. You know what? As soon as I get a whiteboard, I will do this for you. Let's talk about the cosmological constant really quickly. Now, Seth, how are you? So, there will be some math that we discussed. If you are interested, the stuff that I'm skipping today, I covered under Einstein's equations in a previous live. I want to cut to the spot where we talk about the cosmological constant from this text because they explain it a little bit different. It's the same stuff, but I think it's worth reviewing because it's such an important topic. And we were just now talking about the, you know, about the universe here. Milky Way is back. I was gone because I was eating. Thank you for liking the live. Thank you. Milky Way, Death Dragon, how are you? Now Seth, how are you? Amazing Amanda, how are you? Random Guy, how are you? Very nice. Love it. So, in going from the Newtonian to the relativistic form of understanding gravitation, because we can understand gravitation in a Newtonian way, that stuff that I was talking about with the GMM over R squared and, you know, all of that, where the inertial mass turns out to be equal to the gravitational mass, all of that is fairly simple. It's the Newtonian mechanics way of doing things. But then remember, Einstein was inspired to give us a more correct theory of gravitation with his general theory of relativity, where we consider basically massive objects to be able to bend space and time, and gravitation is more of a curvature of space and time. And so there's more curvature near more massive bodies like black hole and neutron stars, and less curvature near you know, in the intergalactic medium or in intergalactic voids. But then we talked about how when you go more large scale, at a scale of around 100 megaparsecs, you see that these everything is more homogeneous and isotropic, and the inhomogeneities are really seen at a smaller scale. Oh, Suji's taking care of Fuji and herself. So now we will talk about the cosmological constant, which is often denoted by the Greek letter lambda. It's a capital lambda. The Greek capital lambda is a symbol for the famous, or perhaps infamous, cosmological constant. This cosmological constant we have also mentioned a few times, several times on the channel. Well, it has a checkered history. It goes back to the year 1917 when Einstein published his first paper on the cosmological implications